Good evening. Welcome to the QCIS channel. Where on this channel you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and this evening I'm going to talk about construction, safety, engineering. Now, that's a term that you might hear when we deal with construction sites, but we have OSHA. OSHA comes out with these standards that must be followed. How to use power tools, PPE. But for the most part, I'm dealing with construction sites because a lot of your injuries happen with slips, trips, and falls. So during this video, I'm just going to give you some information to help individuals understand safety engineering on construction sites, because it is very important when you're working on construction sites that you adhere to all of the policies, because the object is risk management and you want to mitigate a lot of risk while you're on a construction site because there are liabilities. Now, you don't just have safety on construction sites. I can expand it. You have safety in manufacturing. You have safety even in your workplace, even in your house. Everything is under 1929 CFR. Now you have your construction standards, and then you have your general standards, which general applies to your workplace and even your home. But what I'm going to talk about tonight is construction safety engineering. I want to share my screen and want to get into some definitions. Now, when we deal with construction safety engineering, give that back, share my screen again. Fine. There is the definition right here. All right. Talk about construction safety engineering, and that involves the application of, or we can apply engineering principles to design and implement systems, processes, and equipment that prevent or minimize hazards and risk on construction sites, protecting workers and the public. Now, the key activities include work assessment, designing engineering controls like guardrails and temporary walls, ensuring compliance with regulations, and developing self-specific safety plans and training programs to foster a safety culture. Now, here are the core functions of a construction safety engineer. You have hazard identification and risk assessment. And again, safety engineers identify potential risks unique to a construction site, such as falls and heights, hazards from machinery or electrical issues, and they develop strategies to mitigate them. Engineering controls. They implement physical modifications to the work environment or equipment to create barriers or reduce exposure to hazards, such as installing safety railings, temporary platforms, or using remote controlled machinery. Then there's safety planning. The construction safety engineer develops site-specific safety plans that detail how to manage activities with the potential for injury, ensuring that projects, or if you're dealing with products, you're in the manufacturing arena. If you're in construction, you're dealing with projects. So basically, the safety planning here in construction, the engineer, what they do is they develop site-specific safety plans that detail how to manage activities with the potential for injury, ensuring that projects are executed safely and effectively. Then you have your compliance and regulations. That's compliance and regulations. So basically, the safety engineer will ensure that construction activities adhere to all relevant standards and regulations, including those set by OSHA, and they handle the correction of any discovered violations. Then the biggest item, every year we get it, training and promotion. The construction engineer who's in charge of the safety, known as the construction safety engineer, they are responsible for providing safety training to workers, covering topics like the proper use of personal protective equipment, known as PPE, emergency procedures, and hazardous communication. Also, when it comes to reporting and monitoring, safety engineers create reports on their findings and their effectiveness of implemented safety measures, enabling action to be taken to improve site safety. Now, under all of that, there are key concepts and practices such as the hierarchy of controls. So, safety engineering often employs a hierarchy of controls, a system that prioritizes hazard safety methods. That's hazard safety methods, which are hazardous, but hazard control methods. Again, safety engineering often employs the hierarchy of controls, which is a system that prioritizes hazard control methods from the most effective to the least effective, with elimination and substitution being preferred over personal protective equipment. Now you saw this earlier, this term earlier under the core functions. So now you're seeing it again under the key concepts. That's engineering controls. And it's basically physical changes made to the work environment or equipment to reduce hazards. Physical changes made to the work environment or equipment to reduce hazards. And you have your site safety management, which is a systematic process of identifying and eliminating hazards and maintaining safety risks. And you don't want to maintain safety risks, so I'm going to go over that again. When we deal with site safety management, we're dealing with a systematic process of identifying and eliminating hazards and managing safety risks on a job through a combination of tools and practices. Now, we do maintain records. And we talk about safety risk, but we manage safety risk at all times, because the bottom line is to reduce as many accidents as possible on a construction site. Now, biggest item that you need to understand is OSHA standards. Now, OSHA stands for the Occupational Safety and Health Administration. And what they do is they set federal safety standards for construction, and safety engineers ensure compliance with these regulations. Now, something that you need to know too, you can actually become a certified safety professional, and you can get a certification, a CSP certification, which you could put as a designator after your last name if you have the right training for safety. And that can be in any arena, whether it's construction, manufacturing, or the general workplace. Safety is a niche market, but it's needed. So, where can you go to get information on safety? I would say if you are an industrial engineer, because you heard the word system a few times that I just talked about. Well, basically, construction, manufacturing, they're your big, in my humble opinion, they actually have the biggest workforce, construction and manufacturing. Those are the areas that you're going to have a lot of safety issues. So, being an engineer, you can even do it as a civil engineer. You can do it as a environmental health and safety major. I know Indiana State has a major. I know Millersville University of Pennsylvania has a major. But it's very important that we have people who get into safety because there are a lot of safety violations out here. And the bottom line is, I want to give you some information. You're working out there on a job, how to reduce any type of accidents and liabilities. Now, what I'm going to do now, I'm going to go ahead and share my screen again, and we're going to talk about construction, occupational safety, and health. Now, you see in this PowerPoint, start your day by wearing proper personnel protective equipment. That's known as PPE. Now, if you look at this first slide, you can see there's no safety helmet, no eye protection, no earplug. Now, when you're out there working, you don't want to wear too many of your clothes that are loose fitting. Get caught up in something. You could trip. No short pants. No short pants on a construction site. No sandals or field sneakers. You must have safety shoes, particularly steel-toed shoes. Now, on the safe side, you wear your safety helmet, eye protection. Now, there's a lot of noise going on construction sites. So to keep your hearing, because you're going to have hearing tests as well, you can wear earmuffs or earplugs. You're going to have a lot of dust. So the best PPE for dust is a dust mask, particularly if you're out there and you see dirt coming from construction workers excavating. Now, a safety measure for that would also, in my humble opinion, see a lot of dust blowing out there. Make sure they water it down. They have a water truck. Also, you're going to see dust if they're saw cutting. Make sure they have water when they're using the saw cutter. Wear fitted clothing. Now, if you're going to be going up heights, particularly 4 to 6 feet, wear a harness, button sleeves. If necessary, wear your gloves. Keep your trousers in place and wear safety shoes. Now, the topics. I'm going to get into this PowerPoint. I'm going to talk about the importance of construction safety and health. What are unsafe acts and unsafe conditions, accidents and hazards, system controls, job safety analysis, construction safety and health, the program that you should have. And we're going to get into the importance of construction safety and health. Now, with a highly mobile population of workers and different contractors working on dangerous construction sites at the same time, construction continues to be a major cause of fatalities and disabilities. See this chart right here. Type of workers. And generally, if you think about this, you look at this graph, and this is going to tell you something. Your highest amount of accidents happen between 1,300 and 1,500. Now, I have my opinion on it. Some people are coming from lunch. Now, also, you have a number of accidents that happen between 7 a.m. and 9 a.m. You have people getting into work. But when you look at the data and the graphs, this is what determines what kind of designs that engineers need to produce, because records tell a lot of things. Look at the history. You look at who's working out there. Like, let's say most of your tradespeople, your carpenters, your steel workers, your plumbers. These are the individuals with the boots on the ground. These are the individuals out there that are working in the heat. They're working in the cold weather as well. So, looking at this information right here, you look at all of the occurrences when they took place. This is what I call using data to track the incidents on construction sites. And if you have the correct data, it can help you make proper decisions on managing risk more efficiently. Now, something else that you need to understand when it comes to construction and safety. Well, you look at this is called the iceberg theory. And what I mean by the iceberg theory, I'm talking about direct costs versus indirect costs. Now, you have to understand this. When you have the direct cost of accidents, they're going to be medical expenses. It's going to be wasted raw materials, litigation expenses, equipment damage, and insurance premiums. Now, when you look at the indirect cost of accidents, you have one, injured workers. So you're going to have lesser productivity due to an interruption on a day of injury. You're going to have a loss of efficiency and a loss of income. Then you're going to have other employees. They're going to lose productivity due to work stoppage out of curiosity when assisting an injured worker, due to inspection, loss in efficiency out of sympathy to the injured. And then there are going to be additional costs due to the completion of added work. Supervisors, they lose productivity when assisting the injured. They're going to lose productivity due to accident investigation. They have to prepare reports and they have to do inspections as well. Then you have to have replacement workers. So you have to hire and train that worker. And then when it comes to equipment, you're going to have downtime. And this also affects the schedule of trying to get the project completed on time and under budget. Now, we get into unsafe acts and unsafe conditions. So, first of all, what is an accident? Well, it's an occurrence or event that is unexpected, unforeseen, unplanned, and unwanted. So basically, what is the job of a construction safety engineer? Well, they can eliminate, avoid, minimize accidents. So here's how you do it. You basically use this formula. Hazard plus exposure equals accident plus, or not plus, it's or illness. Let me give it to you again so you'll understand it quite clearly. The formula is hazard plus exposure, and that equals accident or illness. So you have your source, you have your hazards, you have safety hazards, you have your health hazards. Now, although there are hazards, you can break those hazards up into two categories as well, because under hazards, you have your direct contact injury, and that's a safety hazard. And when you have an illness, that's known as a health hazard. Now, environmental hazards in construction. This is big. You have your chemical hazards, which under chemical, you have your organic solvents, your heavy materials, gases, acids, dusts. And under biological, you have your virus, bacteria, fungi, enzymes. Now, when we deal with ergonomics, we might not think of this, but ergonomics basically fits the task to the worker. So where you could get an injury or a pulled muscle is coming from improper positioning improper lifting, repeated motion, awkward position. Now, when all that is said, you have your physical hazards, your noise, your illumination, vibration, pressure, temperature, ventilation. And under social, it's a loss of income. And you have some jobs that are going to be isolated. You have inferiority. You have discouragement. So again, under social, there's loss of income, unproductiveness, there's discouragement, inferiority, and isolation. Now, factors contributing to unsafe acts: proper attitude, physical limitations, lack of knowledge or skills. Now, you do have some people who may have been on a job a long time and they think they know what they're doing, but all along they have been utilizing bad habits. And you only find out when it happens to you, and that's how most people think. But we have to get rid of that thinking. We have to look at everybody on a construction project as a whole, because safety is everybody's responsibility. Now, examples of unsafe acts: when we deal with improper attitude, operating equipment without authority, disregard of SOP or instructions. Now, what is an SOP? SOP is a standard operating procedure. We also remove safety devices, use defective equipment, improper non-use of PPEs, horseplaying, willful intent to injure, working while under the influence of alcohol or drugs. We have our physical limitations: defective eyesight, muscular weakness due to fatigue, impaired hearing, short in height, too tall in height, slow reactions, lack of knowledge or skill, failure to understand instruction. Then you're unaware of safe practices. You're unconvinced of safe practices. You're unskilled or unpracticed. So, examples of unsafe conditions: inadequate guards or protection, defective tools, equipment, congestion, inadequate warning systems, fire and explosion hazards, slippery floors, hazardous atmospheric condition, excessive noise, radiation exposure, inadequate illumination and ventilation. So we have systems of controls. Go from source, that's the pre-contact, the engineering control, elimination, minimization, and enclosure of the hazard within our path. Go to the administrative control: exposure, time limitations, safe work practices, signs and signage, training and education, exposure time, limitations, safe work practices, signs and signage, training and education. And the point of contact, PPE, personal protective equipment. And then we have our administrative controls. As you see the dimension, the sign, it's where S&L equals expressed in the unit, the same unit of measurement, S&L. Now, S is the area of the safety sign, L is the distance of observation. So we have S is greater than or equal to L squared divided by 2,000. That's the dimension of your sign. Then you have to understand, okay, what kind of signs are you going to have? You have 3-panel sign boards. So in that sign, you have a signal word, a message, symbol. You also have a toolbox meeting, which is basically a document that you might get in your email. Read it. It has some good information about construction safety and good housekeeping. And then you look at, again, we go back to S&L. Before I go on with anything, that's going to be expressed in the same unit of measurement. Now, something else that you have to understand too. Signs are color coded, and there's a reason. So when you have your safety and it's red, that should tell you something right there. It's dangerous. Your safety green, that's safe. Safety white, it's traffic. Safety yellow, caution. Safety orange, alert. Safety blue, precaution. And safety purple, it's radiation. Then something else. Let's move this over here. We talk about there's a sign for every situation. Notice up here. And also look at your floor. Look at the tape. Orange and black, yellow and black. Also look at your hazard ratings. Look at your safety data sheets, which used to be your material safety data sheets. And something else. Seeing this diagram right here. Lifting. If you're going to lift something by yourself, don't lift with your back, lift with your legs. But if it's too heavy, you can get a piece of machinery. But you have to be trained on that piece of machinery. But also you can have what I call TPI, two-person integrity. Because again, in construction, you can pull muscles. You can twist your ankle, ligaments, to even break some bones out there. So we deal with engineering controls now. Okay. Something that I said a long time ago. False work. Now, what is false work? Well, if you look at construction, you see a lot of form work, you see a lot of shoring, scaffolding. These are temporary apparatuses that construction workers use to basically stand on. They put some of their material on, but you don't want to put too much material on some of the scaffolding. But these are structures, and they have to be approved by a professional engineer, like shoring, requirement to above 1 meter depth of excavation. Then we have the appropriateness of tools and equipment used. Use of guardrails of 1 meter and a toe board of 0.15 meters. Use of fall arrest system for above 10 meters in height. Use of tubular or H-frame as scaffolds for above 6 meter height, and adherence to construction methodology standards. Now, again, false work is temporary structures that are going to be erected during a construction process and will be removed once the process is completed. Again, we call that false work. And we have our prevention of soil collapse. Now, something you need to do when you're out there trenching soil, you want to bench it. Now, there are different ways you can bench it. You have your type A, which is your 3/4 to 1 or 53 degrees. Type B, 1 to 1 or 45 degrees. Type C, 1.5 to 1 or 34 degrees. And you need a trench box. And while you're in the trench, you need a ladder every 25 feet. And again, I have it right here. Ingress and egress, ladder. Now, I say 25 feet. Some say 50. 50 feet is the max. Your minimum is 25. But you still need a ladder to get in and out. Because let me tell you something. I have to get into this again, talk about confined spaces. A trench can be a confined space if you're not careful. Why? Because it's basically, yes, you can breathe, but it's still enclosed. But having ladders, having trench boxes, and having the trench benched or cut to the right angle, it'll definitely minimize cave-ins, because let me tell you something. When soil gets in a trench and you're in there, it's going to suffocate you. Think a boa constrictor is bad. Soil can come rushing very quickly. And once that soil traps you, it's going to be hard to get out. You're going to lose air. And, cave-ins and falls are very big on construction sites. They're the ones that cause, in my humble opinion, the greatest amount of fatalities. And then operating equipment. But see, with safety, everybody needs to be trained when going on a construction site. And also, something to get into is your personal protective equipment, safety helmets, harnesses and lanyards, safety shoes, boots, construction gloves, respirators, dust masks, eye goggles, hearing protection. It's always the last line of defense. Again, here's a job hazard analysis sample. You have your scope, you have your specific task, your potential hazard, and your corrective measures. So, site works, that's your scope. Your specific task, excavation for footing, that's excavation for footing. Now, what's the potential hazard? Open pit, cave in. Also, there's a potential that you can fall into the trench as well. Corrective measures, can barricade, use warning signs. Another scope, reinforcing bar fabrication and installation, specific task, bar cutting and bending. Then you have steel bars. And what could happen when you are cutting steel and get cuts and bruises? So, what's my measure? Wear definitely wear leather gloves. You have to have good housekeeping, safety helmet, and caution signs. Concrete works. That's the scope, the task, concrete mixing. So what's the potential hazard? Cement, aggregate, and dust exposure. So the corrective measure for concrete works is wearing of a dust mask, safety gloves, and construction boots. Formwork and scaffolding. That's your false work or your temporary work. So your task is to install the forms for concrete. However, there's a chance that you could get cuts and bruises, bumps, and you could get splinters. Then you have the wrong tool that you're using. Now, the corrective measure is conditioned tools, wearing of leather gloves, and the safety helmet. Then you have masonry works. That's placing of a CHB, specific task, handling ergonomics. That's your potential hazard. And you have your caution sign installation and proper posture, handling, wearing of gloves, mask, and the helmet. And then you have roofing works, GI sheet covering, that's the task. Your hazard, elevated, falling, sliding, bruises, and cuts. And your corrective measure, wearing of full body harnesses, safety gloves, and safety shoes. And this should also be under quality control as well. Then a big issue, Construction Safety Health Program. That's CSHP. Well, it's very important. Now, when you get a program going, then you're going to have these 22 items. Statement of commitment to comply with OSH requirements, your safety policy, project details, construction safety committee and duties. That's construction safety committee and duties. And you're going to have an emergency occupational health personnel and facilities, safety and health promotion and education. You're going to have a toolbox meeting, which a toolbox meeting is basically pull a safety event out You have a meeting with your crews during the day before they go to work. Then you're going to have accident, incident, illness, investigation, and reporting, PPE, personal protective equipment, protection of the general public, safety signage, construction worker skills certification. This is why you need your OSHA 10 and your OSHA 30 when you're out there working on construction sites. Then you have testing and inspection of construction heavy equipment before you drive a piece of equipment. And even if you drive your own car, you should always inspect it. Then you have control measures on construction activities. And every construction site should have first aid, healthcare medicines. You have some burns, scrapes, or cuts, and equipment facilities. You have workers' welfare facilities, medical surveillance, working hour and break time, construction waste disposal, emergency preparedness, penalties, and sanctions. And then you have attachments. And then safety tips, very important. Your safety is your personal responsibility. Always follow the correct procedures. Never take shortcuts. Take responsibility and clean up if you've made a mess. Clean and organize your workspace. Ensure you have a clear and easy route to emergency exits and equipment. Be alert and awake on the job. Be attentive at all times to your work surroundings. When in doubt, contact your supervisor or manager for instruction, guidance, or training. Never take risks when it comes to safety. Obey safety signs, stickers, and tags. Take short breaks when you keep up a repetitive motion for a long period of time. And sit, stand, or walk with good posture. Report serious injuries immediately to a supervisor and get emergency assistance. Also, keep things in perspective. Hazards may be limitless, so focus on the most likely risk first. And if we fail to plan, we plan to fail. What is not written cannot be done. Now, as a review, on back, as I share my screen, when we talk about safety engineering involves applying engineering principles to design and implement systems, processes, and equipment that will prevent or minimize hazards and risk on construction sites, protecting workers and the public. Now, the key activities include risk assessment, designing engineering controls like guardrails and temporary walls, ensuring compliance regulations, and developing site safety plans that are specific, and of course, training programs to foster a safety culture. And that's what you want to specify when you go on any construction job. And again, it's a career in safety as well. In some of the colleges, Indiana State has a program. You can actually become a CSP, a certified safety professional. The University of Millersville of Pennsylvania has a safety program. And you can make a lot of money in safety as well. Safety is in fire prevention, safety is in the workplace, safety is in construction, manufacturing, safety is all over the place. The bottom line is it's got to be something that you have to adhere to minimize risk. So again, thank you for viewing this content on the duties of a construction safety engineer. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some political and social content, check out my main channel, the 401 Talk Zone Radio Show channel. I generally have videos every Tuesday, Wednesday, sometimes. Just like here, I have videos generally Wednesday and Thursday. So here's where you can find me on YouTube, For the 411 Talk Zone Radio Show channel, you can find me on YouTube, find me on X, formerly Twitter, True Social, and Rumble. And for the QCIS channel, you can find me on YouTube, X, formerly Twitter, and LinkedIn. Now, something that you all need to know as well, if you're taking the FE examination, particularly the other disciplines, and I believe it's on the environmental and the chemical exam as well, you're going to see a part on safety. I suggest you study that material because it's very important. And it might be on industrial engineering as well. Because when we deal with ergonomics, that's industrial engineering. So grab hold of the OSHA, read that, because you're dealing with chemicals, you're dealing with materials, you're dealing with other human beings, so illnesses come about. You're dealing with the weather. Understand what your job is in safety when you're on a construction site. And if you don't know, I'm going to tell you, safety is everyone's job. Once again, thank you for listening and viewing this content. Duties of the construction safety engineer, right here on the QCIS channel. It's on this channel. You get a daily dose of science, technology, engineering, and math. And until next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.